Do you really know what's under the hood of your car? Sure, you'll have the engine, which rolls the car forward, a transmission that ensures that that engine is in the correct gear, and now, more often than not, a turbo. All of these parts have a very specific purpose and a certain way to keep them running correctly. But without a certain level of technical knowledge, it's possible that you won't know exactly what they do and exactly how to keep them running correctly. My name is Gilberto Hernandez, and I've been working on cars my entire life. Everything from this Jaguar back here to a Toyota Tundra. An important trend that we are seeing in the automotive industry, which is highlighted by magazines such as The Drive, is that the number of turbocharged engines over the past 5 years that have been sold to people from dealer lots is dramatically increasing. This is exposing many more people to the area of forced induction, which will increase the need for education on how these engines work and how you are supposed to maintain them differently than a normally naturally aspirated engine. First, I'll begin by highlighting the transition from larger engines to smaller, more turbocharged ones. In the beginning, auto manufacturers were able to focus on the power of their engines. This would lead to the more importance of a larger engine with more power that can combust more fuel and give more horsepower. But as time has moved on, the auto industry has focused more towards an area of gas mileage and economy of their engines. This has pushed for the use of smaller engines, such as 4 cylinders. But with the use of these smaller engines, we have lost a good bit of power in the name of higher gas mileage. This is where the turbo technology comes in. According to D-Sport magazine, this turbo technology is used to level out the playing field that will increase the number of powers to the smaller engines, something more equivalent to the larger ones. This is with the use of technology such as the twin scroll turbo, which has the ability to increase the power across a larger range for the smaller engine to more equivalent to the larger engines. Typically, these smaller engines would use low power so that they can have the higher gas mileage for city situations and areas that require less power. But in the highway and areas where you need more power, you would use a larger engine such as a 6-cylinder. But with this increase and improvement in turbo technology, we're able to get the best of both worlds, both the power in the higher ranges with the turbo, as well as the gas mileage and economy with the smaller engine. Now, because of these increases in technology, you are seeing these engines not only in small sedans, but you can see turbo 4 cylinders in everything from SUVs to trucks now. But with this proliferation of turbo technology, it is very important that people know exactly how they work and how the two types of induction into the engine are different. First, with a normal car that is called naturally aspirated, which is a car without a turbo, the way that air enters the engine and enters the combustion cycle is through a system called an intake. This is a system of piping that is connected to the front of the car or the side of the car that is routed into the engine. This air system can only enter air into the system through either the car rolling forward or the natural pressure that comes from the outside atmosphere. There's no internal piece that can force more air to the engine. It is only limited by what it can intake through rolling forward or through what is already coming in through the outside. For a turbocharged engine, it can force more air into the engine with the use of the turbo. This is because as the engine burns, the exhaust gases that usually would be vented out of the engine can be collected in the turbo, which would spin a turbine, which sucks more air actively through the turbo into the intake system, which can increase the power of a turbocharged engine, giving more power in higher areas. But this introduces you to a phenomenon known as turbo lag. Turbo lag is the phenomenon where you do not get the full power of the turbo until it is fully spun up. This happens because for the turbo to be able to pull air through the engine, it must reach its boost threshold as described by Road and Track. This boost test threshold is the amount of air that is needed to open the valve in the turbo that can actually force air into the intake. This later boost in power is what leads to the equivalent power in the higher ranges, but it's also what allows the turbocharged 4 cylinders to still remain with that better gas mileage in the lower ranges, because the large boost in power is only used in the higher ranges when it is called upon for highway driving and high power situations, while the smaller engine can still be used for the low power situations, completely avoiding the use of the turbo and keeping the combustion down. Because turbochargers allow the engine to function differently, there are certain ways that you need to treat a turbocharged engine differently than naturally aspirated one. The key points are that fluids are very important in a turbocharged engine, especially your engine oil. This is because engine oil not only lubricates your engine, but also lubricates the turbo. A properly lubricated turbo will ensure that there is no metal-on-metal wear within the system, so that it cannot prematurely break, and it can flow air correctly through the system. To ensure that you have proper engine oil that flows through both systems, you must use the dipstick which is located within your car. This dipstick right here will ensure you the level which your engine is at with the oil within it, and it should be close or exactly at your recommended level. Also, it'll give you a sample of the oil, which lets you check the color of it. If the color is light, then you have good engine oil. But if it is black or very dark, or you can see metal chips in it, then it's time to replace your oil. That is because there are some metal flakes that have gone through your system, which shows that there is wear in your engine. Keeping this worn oil can actually damage your engine in the long run, so you do not want to have that in your car. Also, it is extremely important to use engine oil that is rated for your car. On your car, on your engine fuel cap, you will see the exact type of oil that you need to have within it. Use that type of oil. That will ensure that your car can run at its potential. Also, along with having the correct oil type and correct oil quality, it is important that with a turbocharged car, you let the car get to operating temperature. Temperatures are very important for a turbocharged car. This is because engine oil that is not correctly heated will not flow through the system correctly. The viscous qualities of it will not be high enough to reach the turbo and other areas of the engine quick enough. This can cause extreme metal-on-metal wear, which will lead to premature destruction of your engine. Improperly heated engine oil cannot flow quick enough through your engine. So, when starting your car, it is very important that you either let it run for a couple seconds, preferably 45 seconds to a minute, before you drive it, or once you are driving, to not beat on your engine when you're driving it. According to Engineering Explained, a prolific automotive YouTuber, if you push your engine before it has reached operating temperature, you will lead to extreme damage of the engine. Also, when finished with the engine, when finished with driving, it is important that you let it cool down. According to Scotty Kilmer, as your engine goes, the turbocharger can build up lots of heat because of the exhaust gases that are used to spin the turbine within it. If you do not let that turbine cool down, then you can cause premature heat wear on the turbo. This will lead to damage and often destruction of your engine. So it is very important that you let the heat cool off after you let the engine run. Also, letting your engine cool off after you run it will ensure that no engine oil is left within the turbo. Leaving engine oil within the turbo can lead to a buildup of residue that can lead to premature harm of the system and can get in the way of the turbine, causing metal-on-metal wear that can destroy your engine. It is very important that you let the engine run for at least a minute after you finish running your car, so that all the oil can come out and the heat can be dissipated. Also, you must make sure not to lug your engine. This is a practice where at a high gear, such as 5th or 6th, this happens usually on the highway. Because when in those higher gears, usually you are at a lower engine RPM because it is not using that much power. But if you're at these low RPMs and you floor the engine, then your car will inject a large amounts of fuel into the combustion chamber, which will burn very rich. This extremely rich burning of fuel without enough air creates lots and lots of particulates that can flow throughout your engine system. These particulates are very bad because they clog up the sides, most likely the turbo and your exhaust system, which can lead to premature engine wear and destruction of your entire system. So it is very important that when you call for power in your turbocharged engine, you must downshift to a lower gear and then floor the engine. That is how you prevent the lugging situation. So, while forced induction at first may have seemed like a complicated topic, when you really look into it, it is a very important technology because of the gains in potential power and also the gains in fuel economy. And the proliferation of this technology has opened the door for many people to experience this. So, if you find a turbo tucked into your engine bay, it is important that you know what it does and how to keep it running. Because if you do, you can have a very fun time with your car. Thank you.